All right, geometry, let's go. Second week of March, Ed puzzle video. Just starting out with the cell phone policy again. Just letting you know it's game on. I see a cell phone in your pocket, sticking out of your pocket, outline in there, in your hand. Earbud in your ear is game on. You're asking to be yelled at. Just remember, you can always have positive attention. Don't need to have negative attention. Now, second thing, happy news. Khan Academy is here, and I spent a lot of time today putting the links to the Khan Academy assignments. Just add the numbers here. 1, 2. We're starting off with some interleaved assignments. Pretty fun stuff. Interleaved. Spaced assignments, even some review. Algebra, we're going to be throwing in some algebra review. I didn't quite finish, but I finished a lot. Let's see. Yeah, still got to do the first week of June, the last week of May. All right, I'll do that. Right now, we're in March, and we are going to talk about transformations and symmetry. And this week is about reflections and translations. Okay, so I reached back to 8th grade math in addition to the high school geometry. As you know, a lot of geometry is actually stuff from middle school standards, and then we build on it. So let's talk about reflections. Please make sure that you take all the notes and bring them with you to class on Thursday. I will be grading that line of reflection. So every reflection, you can think of it as a flip. So if I take my hand and go like that, it's a reflection. Reflect, reflect. Boom. Behind the washer. All right, so let's get some more vocabulary. The image and the pre-image. So just outline here. This, please draw these in your notes. Okay, draw this whole thing right here. Of course, goes in your notes. And the A without the apostrophe is called the pre-image. Don't say primage. And the one with the apostrophe is called the image. It's the after. The image is the after, and the pre-image is the before. And so how do you know that the pre-image and the image are reflections of each other? Because if you draw a line between the pre-image and the image, that line should intersect the line of reflection perpendicular and also be a bisector. So you see the hash marks, right? So it should be the perpendicular. The line of reflection should be the perpendicular bisector of the segment. And then you know that A and A prime, or whatever they are reflections of each other. Okay? So we're going to use some, I'm going to have to get some patty paper for class here. That you can fold and reflect. May have some. But here, what we can do is we can just kind of estimate here. If I draw it perpendicular and try to make them the same length on each side of the red line, then I know this is going to be G prime. Can do the same thing to make F prime. H prime. And then, that's a rough one. E prime. This is not the best here. But now HG connects. So something like that. Anyway, hopefully you get the idea. Minimize the distance by using a reflection. Okay, so let's read this. Joy wants to select a good location to sell tickets for a dance. Locate the point P such that the distance someone would have to walk from the hallway A to point P on the wall and then to B to the next class in hallway B is minimized. And so we want to use a reflection to minimize the distance. So how do we do that? Let's see. Plan. So we're gonna the total distance from B to P and then to P to G is least when we use the 3 points that are collinear. 3 points that are collinear. Okay. Use the reflection of point B in the line S to find the location of point P. Okay. Draw a line BG. I'm going to pause this one. Okay, so what we're going to do is we're going to reflect point B over the wall here to make B prime. And then we're going to draw a line that is collinear with B and B prime. And then we're going to put point P different color there. Oh, I see. Point P here. And that, because that will be the point that is the shortest distance, because, well, if they're all collinear. That is what this example is saying. All right, so you can put that in the organizer if you'd like to talk about it further. And now let's go on to example 3. Trapezoid RSTV has vertices there. Graph the trapezoid and its image in the given line. Okay, so let's go to Desmos. And we're going to graph -1, 1, 4, 1. 4, 1. 4, -1, and -1, -3. 4, -1. -1, -3. Is that right? All right. And then y equals -3. Okay. So we can see that we have this trapezoid. We're told we have this trapezoid. We can see now that it is a trapezoid. We want to draw the reflection over this line y equals 3. Well, first of all, we have one point that's on the line, and then the reflection is going to be the same distance away. So let's see, this is at 1 and -3. So what is the length of this segment from 1 to -3? That's 4. So if we're at -3 and we want to go 4 more, we got to go down 7. I'm going to go off the graph a little bit. And then if this is, how far is it? This is at 1, and this is at -3, right? And so what's the distance? This is -1. So this is 2 away, right? This distance is 2. So we want to go 2 in the other direction. So 1, 2. So we know that we're going to have a point right here. And then this distance is, well, it's 4 boxes, right? So we're going to go 1, 2, 3, 4. Oh, man. Well, we did run out of space, but that's okay. And so now we can. So we know that the shape is a reflection when the reflection line is the perpendicular bisector of each pair of corresponding points. Okay, and then you can see it's not a perfect reflection because I did go off the graph a little bit because it's the bottom of my screen and I'm annotating, but hopefully it's enough to give you the idea. And the same thing for 3b, only the x equals 2 is a vertical line at x equals 2. Okay. Please make sure you have this key concept in your notes. So it's just giving you a shortcut rule for reflecting over the x-axis and over the y-axis. And example 4. So if we're reflecting all these points over the x-axis, then the rule that we just saw says change the y. So E prime would be -4, +1. F prime would be 2, -2, and so on. We just change the sign and the y coordinate. And if we're reflecting over the x-axis, we just change this. If we're reflecting over the y-axis, we just change the sign and the x coordinate. So this J prime would be at -3, 2, and so on. All right. And there's another key concept. Reflecting over the line y equals x switches the coordinates. So xy changes to yx. In essence, well, 2, 2 would still stay at 2, 2, but 4, 1 would change to 1, 4, and so on. So you can see that. So we have our different shortcuts. Make sure you memorize them. Not too bad. In translations, if we can go on to that, they're not too bad either. Okay, so where reflections are flipped over a line of reflection, translations are when the shape is moved across a vector. A vector determines the direction and magnitude of the translation. Okay, so you can see we have this vector here. So the length of it is how much the shape will move. And then the direction of it means it will move in that direction. So QPR would just move up like that. You can see the example here. The blue shape moves the green shape based on this vector right here. Okay. When we have the coordinate plane, it makes it a little bit easier because all we're going to be doing is adding and subtracting from the x and the y. And also you should know how we write a vector. Instead of parentheses, we use these, almost like inequality signs. So 7, 4 means add 7 to the x. That means x, all x's plus 7, and y, and then the 4 here means all y's plus 4. That's what that means. See, it's right there. So let's see if we can get an example of that. So here we are, 2a, triangle ABC with the vertices there, and then we're going to translate it across the vector -4, -1. So we're going to subtract 4 from each x and 1 from each y. So what would a prime be? What's 2 minus 4? What's 6 minus 1? A prime would be -2. and 5, and so on. So you just do that for all the coordinates, and then you graph the new image, and you have your translation. Marching band. If you're going to make a design for a marching band, you're going to need to use vectors so that everyone's moving along the lines where they're supposed to. Animation also uses vectors. A coin is filmed using stop motion. Describe the translation from A to B. So how would we do that? Well, let's look at how far. 1, 2, 3. So from A to B, it moved 3, positive 3, and then also moved up 1, 2. So the vector would be 3, 2. Easy. And from A to C, and then you can do that. All right. So hopefully it's a nice, easy start to transformations, and you really enjoy it before we get into, the dilations and the preserved properties and the sequence of transformations to get a good foundation this week.